Hello, Rabile. You're the first person here today.
Yes, good evening. How are you?
Good evening. I'm doing very fine. You?
I'm good, thank you.
All right. Steve has joined. Welcome, Steve. So, how was your week?
My week was good. I actually passed the first certification on Wednesday, so that was good. Yeah.
Ah, wonderful. Congratulations.
Thank you. How was your week?
It was very fine.
Yes,
Hectic. We're not complaining. We'll do our best. But
yes,
generally, it was good. It was good. So,
that's
how was
good.
the exam? How did you find the exam?
The theory part was, it was good. It was fair, but then the practical part, I had to redo the practical part because there was some point where you have to see if what was it like. I think a course was enabled or disabled, so you had to manipulate the data with SQL to match all those cases, but I eventually found it on the second attempt. Yeah,
Oh, that's fine. Congratulations.
thank you.
So, you've enrolled now for the Python, right?
Yes, yes, yes.
Okay, and I want to believe you've completed last week's assignments.
Yes, just I did not finish the introduction to Python one, but I'll finish it by this weekend.
All right, all right. Well done. Keep progressing.
Thank you.
Steve, good evening.
Hello, good evening. Can you hear me?
Ah, yes, we can. How how are you doing now?
I'm fine. And you? How was your week?
Doing well. Pushing it a bit. So how far? How
Okay.
have you been progressing?
Uh, I've been progressing slowly. It has been a lot. I've registered for the certification, so I'm going to take it this evening. Um, there was a particular section I was actually trying to get properly before I take it. So I think I figured something out. So I'm going to attempt it this evening. Yeah. Then I've
Oh,
registered for the Python track. It's just one, the part three of the chapter. That's the chapter three, the third section that's remaining for me to complete. Then I'll be done with introduction to Python. Then I'll move to the next course, hopefully today or tomorrow.
all right, all right. That's fine. At least I'm happy you're progressing. As long as you've registered, it's something that within 30 days you should be done with it, so or less. So
Yes.
congrats. That's fine.
All right. Thank you very much. I really appreciate it. All thanks to you.
No, Raphael, evening.
Good evening, Ogochukwu, and good evening, everyone. I hope you're all good.
I'm fine. I want to believe I can speak for others if I say they're also fine.
Ah,
I'm good. I'm good.
oh, good, Steve,
Oh.
good, Steve. Marvelous, and Ora Bile and Ibrahim. Yeah,
Ibrahim and
so
Marvelous, welcome. Sorry, Raphael. Ibrahim and Marvelous, welcome and good evening to you too.
Good evening, everyone. Good evening, ma'am. Good evening, everyone.
Good evening. Thank you.
Yeah. So Raphael, please, you can continue.
okay. Well, nothing much to add. I've started with my Python track. And like I said last time, it was what I was doing before we started our SQL. So it's something I've done already. So I'm just working on it and seeing how far I can go with it. So that's all from my end, Gochuku. Yeah.
Okay.
Thank you.
And the certification.
Yeah, I've gotten it. I've gotten both. Yeah.
You see, you didn't want to tell us. Raphael.
Oh well, kind of. Since it's not, it is way past the class already. That's why I didn't want to add that.
I know it doesn't matter. At least it's something. You've gotten the SQL and the Python certification, so it's something to be joyful and about and all that. So, congratulations!
Yeah,
I
yeah,
saw it on your dashboard,
yeah,
and that's why I mentioned it.
yeah.
Congrats!
Oh, okay. Thank you very much.
All right, you're welcome. Uh, Caleb, so you're raising your hand. Good evening.
Oh, good evening, ma.
Good evening.
Ma, I wanted to ask if I can still continue with the data camp. I want to know when the deadline is.
Hmm. Okay, I'll talk about that when we finish today.
Okay,
Um.
because you said that the ma, because you said that the XP before was 50K, 50,000, but they reduced it to
Mhm.
30,000. But I've passed
Mm.
half of the 30,000, so I don't know. Maybe within this week, I'll be able to meet all the requirements. That's why I'm just asking.
I think you sent me a message on Discord, right?
No, I didn't.
Okay, you're not the one who sent me a message. Okay. All right. After the class, just remind me. I'll talk about the probation period and all that, please. Then I saw a message
Thank you.
from uh Rabile. I don't I don't really understand. So maybe after the class you could ask, please.
Yes, I'll ask after the class. Thank you.
All right. Thank you. So is 6:08. I think we've given enough time for others to join us and we can start now. I sent the slides on our Discord. I need someone to help me out, please. Just project if you're using your PC or your laptop. Is anyone helping us with that?
I'm currently using my mobile phone. I'm trying to see if I can switch to my PC.
Okay, thank you. So while you do that, I believe we can just start. I just slides. We can start while we wait for you. Very
Okay.
necessary. All
Okay.
right, thank you. So I want to formally welcome all of us to today's session. Today we'll be talking about the assignments for last week. That is understanding cloud computing and Python. So last week, first of all, we talked about an introduction to Python, and most of the chapters in the intro to Python class, we did last week is actually part of the assignments for this week. So we wouldn't go back into much of that again. Unless someone has a question concerning that, you can ask after the class. So last week we talked about Python and its use case in data engineering. We talked of Python functions. We mentioned we talked of Python functions, variables. We looked at if statement, that's the conditional statement. We looked at loops, functions, and so many and other aspects of Python. Then at the end, we wrapped everything up by writing a Python script that requests for a password per se from a user 3 times and gives the message either the password is right or wrong. And after the class, after that, I made like a suggestion or a comment that you could try using it on your own. You can try rewriting that script using a while loop, because the one we used a for loop to write it, to count it 3 times. So I suggested that you on your own, you could try using a while loop to see if you can get the same thing. I want to know, by raising of hands, did anyone attempt it? Did anyone try it? Silence. So no one did. All right, no problem. It was just something to attempt. No problem anyway. So let's continue. In our first week, in our first breakout session, where we talked about understanding data engineering, we talked about some components of data engineering. We mentioned traditional and modern database. We mentioned ETL. We mentioned ETL pipelines using Python. We talked about SQL. We talked of big data, and that led us to cloud computing, which we mentioned in the first week. So I'm also going to work on the assumption that the assignment that was given last week, at least the first course to complete, is understanding cloud computing. So I'm working on the assumption that everybody here has completed at least one assignment, which is the first course, understanding cloud computing. So based on this assumption, I would like someone to help us, in his or her own words, define what you understand by cloud computing. Can someone hear me? Marvelous. Okay, Marvelous, let's hear you, please.
Okay, cloud computing is an enterprise-based industry whereby computing services um are, are served online using the internet instead of having on-premises computing infrastructures. So those computing infrastructures are hosted online or on the internet, and they are sold as services to industries or users that need them. That's my understanding of cloud computing.
Okay, that's very fine. Can we get another definition? Can someone just tell us, in your words, what do you understand by cloud computing? No one is speaking. All right, so let's move ahead. Basically, as Marvelous said it, cloud computing is making use of another person's resources over the cloud. That's making use of remote services for data management. It's not like on-premise. On-premise is getting your own servers in your company and hosting your own information. But when we talk of cloud computing is use of remote servers for data management and other services. Now, some of the benefits of cloud computing is that, one, it is scalable. Now, by scalability, we mean, is it the fourth slide, please? Thank you, Ibrahim. So, one of the benefits of cloud computing is it is scalable. When we say scalable, we mean you can as the needs, the data needs of an organization keeps growing, you do not need to start looking for additional resources to meet your data needs. Being scalable means that as your data need is expanding, you only need to purchase additional resources from your cloud service providers, and they will expand. They will keep expanding to accommodate your needs. So say for example a company needs say 50 gigabytes, just using it as an example, say 500 gigabytes of cloud storage, and as time goes on their data needs kept increasing and increased to say 1 terabyte. What they just need to do is not to go and start buying external resources to increase, but simply pay their cloud service provider to free up more resources for them that would accommodate their data needs. So that is what scalability means in terms of cloud computing. Then it saves costs. How does it save costs? Now you do not need to build a server room for your servers to start buying hardware resources to store your data. The monetary cost, the cost of maintenance, the cost of building such a servers could actually be used to pay a cloud service provider, and you would get exactly what you need. And using cloud services in this aspect would cost you less than it would if you choose to do an on-premise data storage. Then we talk of availability. Availability here in the sense that it is always available. No matter what, you can shut down your system, but the storage in the cloud, whatever infrastructure you have hosted in the cloud, will always be available, except one thing happens, like or except something like very huge happens, then you can talk of, then it could fail. But aside that, under normal circumstances, it is always available. It's not something that would easily crash, just like a regular PC or a laptop. Then you talk of accessibility. Accessibility in the sense that no matter where you are, you can access it. If you are in Nigeria today, you upload some things to the cloud tomorrow using another device. If you're in Nigeria today and you upload some things to the cloud using a device, if you change location to another country using another device in another country, you can still access those things that you placed on the cloud. It is accessible wherever you go, as long as you have the privileges and the keys to access those things. So it is always it is very accessible, unlike putting something on premise, unlike storing something on premise, and if anything happens to that your storage unit on premise, there will be a huge fallout of that for the organization. So with that, I would like to ask another quick question. So from what we know about cloud computing, from the benefits, some of the benefits that we've outlined, and from what we have studied so far, I would like someone to attempt this question. So why do you think that a laptop would not be good enough for large data processing?
Okay, let me try to attempt it.
Okay. Please go
So,
ahead.
okay. So generally, if we talk about the architecture of our PCs, so most of the time we said our PCs used to have cores, which are the different sections it uses to protect and process data. So I think most PCs will have like 8 cores. If your PC is good, 8 cores, 16 cores. So it means if you want to process large data set, you can't be using a single core to process data, like large data, because it will be very slow. It will take a lot of time. That's if it will not even crash the system itself. So you need a lot of processing power in large data, and 8 cores will not be enough. So one good thing about cloud computing is that it runs in clusters. So if you have a large job, you can split the job into multiple clusters for fast processing. But for a PC or a computer that doesn't have such clusters or enough clusters to run such large scale job, it will take too much time, which might not even run. And then there might be that limitation of storage. When we talk about big data, some big data run up to, like they say, petabytes or terabytes. So most PCs will not have that storage capacity. I think some will use 500 gig, at most 1 terabyte. And then if you exhaust the entire storage on your system, even if you go like 70% of the storage already, your system will start hanging because it needs space to run other processes. So that's one reason. I think the fact that it lacks enough clusters to run most tasks, and then enough processing power and storage. That's one reason it might be difficult to do big data, because big data is in terabytes. Okay.
All right. Thank you very much, Steve, for that. You said you just gave us about 3 reasons, not one. So that's fine. You mentioned limited storage. Very, very true. PCs do have a limited storage. If you have your PC, it's either 256, 152, 1 terabyte, and the rest of them. So it has limited storage. And when we talk of big data, we're talking of data that could run into millions of rows. And of course, most of them are above 1 terabyte. So it's working with your PC or a laptop would, based on limited storage, it would not run properly. Then he also mentioned performance. It will definitely slow your PC down. Even if you run if you're using a PC that's 512 megabytes, we're talking of CPU capacity, and if the data you're using is say 400 and something, that will surely run down your PC, because that is not the only process that your PC will be running at that moment. Your PC will be running other processes, including the one of 400 and something megabytes, and that would eat up the whole of your space, your memory, the PC memory, and probably crash it also. So based on some of these reasons, we can see that PC is not, or a laptop is not really that reliable when we're talking big data. And that's one of the reasons again why cloud computing is very essential as a data engineer, because we're talking of data that runs into millions of bytes, millions of rows. How do you transform this data? How do you do it in batches? How do you do it concurrently? These are things that just a PC cannot handle. So it's all easily handled in the cloud, because just like we mentioned, in the cloud you can get when, depending on the service provider, you can get virtual machines that depending on the size of the job you're running at that moment, it would share these jobs into different it will share these jobs. That's a parallel computing. It will share these jobs and run all of them at the same time. And these are some of the things that your PC or your laptop cannot do. So that brings us to cloud in data engineering. So first of all, data is too big to be processed on our PCs and our laptops. So that's why it is essential that we run some of these processes on the cloud based on the amount of data that we are working with. Then there's also need for real-time processing. If we're talking real-time processing, we mentioned that the number of data being generated daily is about 400 and 403 million terabytes. That's the amount of data being generated on a daily basis. Now, what this means is that the storage, where are we going to get to store? Where do we get to store this amount of data? Aside that, you look at platforms like social media. We're talking Twitter, Facebook. These social media platforms that deal with real-time data. If they need this information real time to see what people are tweeting, yes, to see what people are tweeting, these are things that are actually needed real time to get the top trends in a particular location. These are informations that are this is information that is needed real time. So it's so as to outline the top trends in a particular location. Now, these are the things that cloud computing helps us do, because you can't get this type of real time information if you depend solely on a an on-premise system. No, rather it's through the cloud, by using cloud systems, that you're able to in real time get the number of trends. And that's why when you look at a trends table, you see that 1 minute you see A is trending, and in the next minute something else is already there. So these are real-time data that can only be done. These are real-time things that can only be done using cloud computing. Then we talked of the need for storage and processing power. That has already been mentioned. Because of the lack of storage and processing power in our PCs, or that is required by big data, the best bet is always to use the cloud when working as a data engineer. Then lastly, we said it's essential for modern data pipelines. We all know the way things are changing. We all know how tech is changing. Today we are getting that 403 million terabytes of data is generated on a daily basis. By this time next year, I'm very certain that the number of the quantity of data generated daily will definitely increase. So as these figures keep increasing, there comes more need for us to understand more this about cloud and its infrastructure, to understand more about cloud computing and how it's being used in data engineering, so that as the data being generated daily keeps increasing, you already have a good system in place to accommodate the data as it keeps increasing. And as a result of a cloud and cloud computing being scalable, it would easily accommodate the continuous increase in the data that we keep generating on a daily basis. Then we'll talk of types of cloud deployment models. We have basically 3, but 4 here. So we have the private. Please go to the next slide, Ibrahim. We have the private, we have the public, we have the hybrid and the multi-cloud or community cloud. Now, private is more secured. It depends on the needs of a business. They can decide to have a private cloud as their own. Now, this private cloud is strictly for them. It's strictly for that company or that organization, as the term says, private. Then, if you talk of public, public is the shared cloud storage or cloud service. Now, like the popular ones we know, the AWS, Amazon, and the rest, they actually offer public models, because you get to buy the service, the cloud service you need. You get to pay for it from these companies. Then we talk of hybrid. Hybrid is a combination of both public and private cloud model. Then talking of multi-cloud, multi-cloud is when more than one cloud service provider is used. Now, multi-cloud is also hybrid, but the difference here is that more than one service provider is used. For example, a system or a business that uses both the cloud services of AWS and GCP, that is a multi-cloud environment. Whereas a hybrid makes use of both private and a public cloud. So we look at cloud providers. The popular ones are with AWS, which is the short form for Amazon Web Services. Then we have Azure, which is owned by Microsoft. Then GCP, which is Google Cloud Platform. Now, these are different cloud providers. They provide the same infrastructure on the cloud, but they provide the same infrastructure on the cloud, simply that they are different companies. It's just like using Google Slides and Microsoft Excel. They're all the same thing. They provide basically the same cloud services, but are owned by different companies. Then we'll look at the type of cloud services that these different platforms have to offer. Then when we talk about cloud storage, Amazon's cloud storage is known as S3. Azure is known as Blob. Then Google is known as GCS, which is Google Cloud Storage. Then you talk of compute. Compute is when you talk of providing processing power. Amazon has the EC2, which is Elastic Compute Cloud. Azure has the ACS, that's Azure Compute Service. Yes, I'm correct. Then GCP has the GCE, which is the Google Compute Engine. Then you talk of ETL tools. ETL tools means their own tools for transformation. Amazon has the Amazon Glue. Azure has the Azure Data Factory. Then Google has the GC Data Fusion. Then we talk of data warehouse. We have Amazon Redshift from Amazon, Azure Synapse Analytics, then BigQuery from Google. Now, these different services are not exhaustive. Amazon also has Databricks, and they also have, I think, Dataproc. Then for compute, they also have Lambda and all of that. So these are not exhaustive. It's just a list of the different services and the different services offered by these three most common cloud service providers. Then if we want to run like a simple ETL process using AWS, ETL in the sense that we want to just load data, transform it, and we want to put data into the system, transform it, and load. What we simply use is, first of all, from our CSV file, we load it into the Amazon S3, which is Amazon's storage system. Then next from S3, it goes into the AWS Glue, where the transformation occurs, and after that, it is stored in the Redshift warehouse. After that, it's stored in Amazon Redshift warehouse. So that's just like a simple ETL process if we want to use only AWS. If you want to use the other service platform, we can see what they have to offer, and also run the ETL, the complete ETL using these platforms. Then we'll talk about Python in data engineering. So basically, in a data engineering project, Python we collect data, we clean and transform data, and then we load this data. Now, each of this process is achieved by defining a function to run each process. And that's why it's important that you understand how to define functions and you're comfortable working with functions, because in writing Python scripts for your ETL, it's actually functions that you're defining for each process. So when we talk of collect is either the data extraction or the ingestion stage. Now you write a function, define a function that will handle the collect process. Then next, you go to the clean and transform process. You define a function that would clean the data and transform it into rows and columns that are comfortable or that are good for analytics. Then finally, you define a function that will load the already cleaned and transformed data. You load it into a database, or you can still convert it to a CSV file, but mainly it's being loaded into a database. So you define a function for each of these stages at every in your project, and after defining these functions, you call the functions and execute the complete project. Then we look at libraries. Now, one of the things that we use commonly in Python is Python libraries. Python libraries are a collection of modules and functions that make programming easier and efficient. Now, this simply means that a library is like a collection of code. Now, rather than us writing repetitive code, programmers have written these codes for us and packaged them in what is called a Python library. So when you want to use this Python library, you do not have to start rewriting these codes all over again. You simply import the library into your Python environment. After importing the library, you select the function you wish to work with, and by calling on that function, you can easily access every feature of that function to work on your project. So we have so many libraries in Python, and some of them are matplotlib, pandas, JSON, Seaborn, which other NumPy, and a host of others. So there are so many libraries in Python that we use to work in data engineering. So to use a library, we have to use the import keyword. That is the first keyword that you use. So for example, we want to import the pandas library. Standard way of importing it is using import pandas as PD, as shown in the example. Also, we have an option of importing a single feature or a single function from each library, because like we mentioned, a library is made up of it's a collection of functions. So you can choose to import just one function in a library rather than importing everything. So to import say data frame is a function in pandas. So to import only the data frame function, what we use is the statement written on the last line, which is from pandas, being the library pandas. From pandas, you import data frame. Let's not forget also that Python is case sensitive. So a small letter D is not the same as capital letter D. Then we look at the requests library. Now, this is a library that we are going to be very, very familiar with in this Python class, because the request library is what is used to interact with web servers and APIs. It's the request libraries that we use to make HTTP requests and to extract data from websites. So when we are working with APIs, we use the requests library. Now, first of all, the request library, it doesn't come pre-installed. No, it doesn't with Jupyter. I think I installed mine. It doesn't come. I don't think it comes with Jupyter, but with VS Code, that is certain it doesn't come. So anyway, you can first of all check if you have requests in your Python environment by running pip show requests command on the command line, and that would give you the version of the requests library in your environment if it is available. But if it isn't available, you will get an error that the module or library was not found. Now, to install it, still on the same command line, you just type in pip install requests and it will install the requests library if it isn't in your environment. Now, the basic and the standard way to use the import requests, to use the requests library, is simply import keyword first, then requests, and that imports the requests library into your Python project. Then we look at the NumPy library. NumPy is simply numerical Python, and as the name implies, it is used for numerical calculations. That is what NumPy is basically used for. It's used for numerical calculations, scientific computing, anything calculations, arrays. That is what we use NumPy for. So the same method, if you want to check if you have it installed, you use the pip show. Now, NumPy comes with Jupyter. I'm certain of that. It comes with Jupyter Notebook, but it doesn't come in VS Code. In VS Code, you have to get all the libraries that you want to work with. Then to install it, we use the pip install numpy command. And also the standard way of importing numpy is import numpy as np. Now this imports the entire library, and for you to import just one function, we use from numpy import array. Now that is import. Can you hear me?
Yes, we can hear you now.
Oh, okay. Oh, sorry. Thank you. So from numpy import array imports the only the array function that is present in numpy package. Then we'll talk about pandas. Pandas is like the most common library when you're working with data. If you're working with data and you don't understand pandas, then I don't think you're working with data. You just have to understand pandas, because pandas is like the key, especially when you talk of transformation, when you talk of data manipulation, when you talk of data cleaning. It's mainly pandas, because it has so many functions basically built to work with data. So pandas is one very important library that we should know how to work with, and also ensure that we read the documentation. Now, before you write 3, 4, 5 lines of code, you check online and you check and see if there is a function in pandas that can easily help you handle that before writing 3, 4, 10 lines of code. That function will help you easily cut off that number of lines of codes and make your programs more readable and easily understandable. So now, to check, as usual, to check if you have Pythons installed, you use the pip show pandas. This also comes in as one of the libraries when you install Jupyter Notebook on your system, but it doesn't come with VS Code. So to install that, to install pandas, you use pip install pandas, and the standard way to import this is simply import pandas as PD. Now this imports the entire pandas library, while to import just one function, for example the concat function, to import just the concat function from pandas, we use the statement from pandas import concat. Then we'll just look at a simple ETL workflow using Python. First of all, to collect data, the libraries that we used for this is the requests library, if we're extracting data from an API or over the web, or we use the pandas if we are just simply ingesting a CSV or an Excel file. So we use the pandas library for that. Then when you talk of cleaning and transformation, working basically with data, it is mainly pandas that is used, while numpy is used if there is any numerical calculation that we need in during our data transformation stage, then the numpy library can come in. But notwithstanding, the main library being used for data cleaning and transformation is actually the pandas library. Then finally, we load using SQLite 3 or SQL Alchemy. Now, SQLite 3 comes preloaded. Yes, it does come with Jupyter, but as usual, you need to pre-install it on VS Code. So this is just a simple ETL workflow if we're using Python to write an ETL project. So we collect using the request and pandas library, we clean and transform using the pandas or numpy library, and then we load to a database using the SQLite or SQL Alchemy libraries. So that's what we have for today. So that's what we have for today. If anyone has a question based on this, please, you can ask. Marvelous, please, let's hear you.
All right. Thank you for today's lecture. Actually, I have two questions. First is it's not about this particular lecture. It's about the SQL assignment. So I just got in touch with the I got in touch with the assignment sent. So when I checked the documents, I couldn't find any source data. So I want to ask if that is how it's going to be, or it was just an error. So that's my first question. And my second question is about today's lecture. How in a typical data engineering project, how to use SQL and Python together, because today in today's lecture you made mention of using Python for virtually everything about the ETL process. So if if the ETL process is mainly for if Python is used for mainly the ETL project, then where does SQL come in the train of the process? So that's my question.
Okay, thanks for that question. So first of all, you mentioned the capstone project. Now, there is no data on that project. You don't need to work on it with data. Just the tables provided is enough for that project. That's the only thing you need. The tables provided are actually enough. However, on your own, after completing that project on your own, you can simulate data. This on your own now, as outside the submission, you can simulate data into the table. That's the first table provided, and then see how it works when you have finished with the staging and the staging and the presentation tables. So you can simulate data on your own to see how everything works. But for the project, no raw data is needed to solve that. Then you asked, in where does SQL come in? Now, after transformation, SQL comes in when you're talking of loading the last stage, which is to load the data after transformation. After extraction, you do the transformation. Then after transformation, you load it. It's mainly being loaded in an SQL database or a data warehouse. So that's why in the cloud computing part of it, the first instance there, where the example I used for AWS, S3 is the bucket, storage bucket for AWS. So that is the ingestion part of the cloud, AWS cloud service. That is where you put in data. So after transforming and working with your data on a Python environment, you can load it into a database. And where that database is stored is, you can those who need it, the analysts and the machine learning experts, and those who actually need the data you have transformed, they will get it from the storage location, which is either a database or a data warehouse. So the loading part of all of this is where SQL comes in. The extraction part could be from an API or from a CSV file. The loading part is in Python. Then, sorry, the transformation part is in Python. Then the loading part goes to an SQL database or a data warehouse. I hope that answers your question. Marvelous.
Yes, ma'am. Thank you.
All right. Caleb, please, you're raising your hand.
Oh, good evening. You said that you're going to explain on the probation after the session.
Oh, okay. Let me even get, sorry. Before I do that, let me send in the attendance. Where is it? I'm coming, please. Let me get the link and send before I forget. Where is this? Can't seem to find this. Oh, okay. So let me send in the attendance link. So you can write in your attendance before I attend to that question. Okay, so I've sent the attendance. Now for the approbation period, yes, the number of XPs has been reduced from 50,000 to 30,000. That's one. Then it was extended to end of month, and end of month is next week Tuesday. So it was extended to end of next week Tuesday. So by Tuesday, please, those that are yet to get the number of XPs, that's the meet the basic requirements for the probation period, get a minimum of 30,000 XPs, complete 3 courses, complete 2 projects, and then 50% attendance to the breakout session. So yeah, these are the 4 requirements. So you still have time between now and end of the month, which is next week Tuesday. So that's what we have for now. The
Excuse me.
requirement was reviewed recently, and so the XPs were reduced.
Okay. Excuse me, ma. I've let me say I've completed like majority of it. It's just meaning one project and the XP. That is all.
Have you done 2 projects? I know
Yes, I
we've
did. Yes, I did one project. I completed one project. It's not remaining one more.
I know we're giving out 4 projects right now. That's 3 on data camp, and 1 was just the simple assignment, which was submitted via Google form. So out of these 4, you've completed only 1.
Yes, the project is on public health in university. I'm sorry, mental health of students in university. I completed that project.
That's the first project. Okay.
Yes.
You still have between now and Friday. I think you can work on a project and finish one this night. If you
Okay,
check the
thank you,
past
ma.
ones you've assigned, you can finish one project this night. It's just like 2 or 3 questions that you ask, and as since we've already handled these projects in our sessions, I know we handled 2, okay, no, 3. We talked about 3 of them in our sessions. So it shouldn't really be that much difficult for you to handle. I think after this session, you can just go ahead and complete one project. Then let's just talk about the 30,000 XPs then.
Okay, ma, thank you.
All right, you're welcome. Steve, you've been raising your hand up. Please, what?
Okay, I hope you can hear me. So my question is, we've learned, I did a boot camp this weekend. It was a 5-day boot camp on cloud computing, cloud platform, the like security, cyber security for cloud platform. And we're introduced to different sections of the different platforms, AWS. We have AWS, GCP, and Microsoft Azure. Now, okay, most organizations will tell us, okay, this maybe they have proprietary, maybe if they use a lot of Microsoft apps, they would want us to work be acquainted with Microsoft Azure, or if they work with Amazon Web Services, okay, AWS or Google, if they work with Google platforms. Now, where does other tools that we are going to learn, like I know there's one called DBT, that's is it database tools or something. Then there's Snowflake. Yes, I know Snowflake and DBT, and there are some others that are still there for data engineers to use. How do we know which to learn, what to learn, and what to use and apply? Because I was checking some portfolio projects for data engineering using Microsoft Azure or AWS, and there are so many segments like creating. I know there's one that you need to create a bucket and some other things. So, what's your advice for navigating through this so that we don't learn some unnecessary things and then just too much information? We just so to avoid too much information.
Okay. All right. So, from my point, the tools are like after mentioning those three, I said they are not exhaustive. Some of these, the ones you mentioned, they have integrations with some of these major services. So though there are different companies, but you can still combine and work with three of them. That's in a multi-cloud environment, depending on the use case in the company or the organization. Now, and you find out that if you decide to learn Amazon, if you decide to learn AWS, you will have to learn from S3 down to Redshift. You will have to understand how data is moved from the bucket and how it undergoes the various transformation stage and goes to the data warehouse. If you learn that for AWS, you will still need to learn that for Azure and for Google also. Now, to avoid this too much learning too much of everything, and it seems like you're now becoming a jack of all trades. Here is what I actually did. First thing, you need to know. First thing, what do you want to get from data engineering? Now, when you answer that question, you will now ask, look at the company you want to work for. Now, as a data engineer, do you want to work with company A or company B? Now, you look at those companies that you want to work with. If your company of interest is Meta, you search for their data engineering job adverts. When you go to the adverts, you look at the tools that is being requested. Those are the tools that they actually need in that company. So use the tools that they wrote in their adverts to form your own learning paths, so that you do not go ahead and start learning too many tools. Check for your company of interest. If you want to work remotely, check for the country you want to work for, the country you want to work in, the company you want to, your companies of interest. Check for the adverts concerning your area of specialty, data engineering in this case, check for the adverts. In the adverts, you definitely see the tools and the requirements. You see the tech stack, you see everything that they need, and that will give you an idea of the setup that they have in the company. So work or learn based on the tools that they have listed there. So that will form your own learning path in data engineering. Then when you want to work on projects, you work based on those tools that you have learned.
Okay.
Is that fine?
Yeah, yes, it is. Thank you very much.
All right. You're welcome. Chinwendu, you're raising your hand. Please, let's hear you.
Okay, good evening, Mama. So my
Good evening.
question is on the projects that we are supposed to complete for the probation period. So I know that we've done mental health and something about London, something. Those are the two projects that we've done on data camp. The one on the SQL project that you gave, there was no link for the submission. I can remember I asked about it last week, and they said you provide one. So I want to ask, does that also count as the project that we need to complete to be eligible for as a passing criteria for the probation period?
Okay, so first of all, we're talking there for the SQL projects. I'll count it now as 5 actually. 3 given on the platform, that's on data camp, and 2 outside the platform. So I don't know which of the 2 you're asking. Is it the one that was given like sometime last month or thereabouts, or the one given like 2 weeks ago?
Yes,
Okay,
2 weeks
that's
ago.
given. That was okay. Yeah, I'll have you get the link is not available yet. You get that on Monday. I'll send in the link on Monday to the channel. Someone also requested for that link, so if he sent me a DM. So you get it, please, on Monday. I'll send that to the channel on Monday. So the link is not available at the moment. That doesn't count, but if you've completed it, fine. That counts for the AICA certification now. That's where that one counts. That's this second SQL project, the capstone. It counts for the AICA certification. It isn't part of the ones for the probation period.
Okay, ma. Thank you, ma.
All right, you're welcome. So, Arabile, hey, you asked the question earlier. I needed you to clarify that question. Something about the data associate. I don't know what you mean. Do you mean the exam? Okay, please.
Yes, I was asking about the certification because I think I did the data engineer associate this week. So should I register for the data engineer exam also, not the associate one? On data, yes.
Okay, so the data engineer is after you have completed the Python track. That's when you'll be eligible to take the data engineer exam certification exam. After you have completed the Python track. So if you've completed the Python track, of course you can register and take the exam, the certification exam. But if you haven't registered, if you haven't completed it, then you're not eligible. Now, there is something
Yeah.
I don't know if this is still bringing confusion, because I know in most persons assignments that would still be reading as incomplete. Now the reason is this: data camp has no assignment for the associate data engineering certification exam. It has just one assignment for certification, which is the main data engineering certification. Now that was just put there so that as a reminder that you register and take the associate examination. If you've taken it, it will still be reading incomplete. So don't worry yourself. As long as you've taken and completed the first part, which is the associate, just go ahead and continue with your courses. You can only be eligible to take the main one after completing the Python track.
Okay, thanks. Makes sense now. Thank you.
All right, you're welcome. Chungwendi, you're raising your hand.
Yes, ma. Okay. My question is concerning the timeline for the certification exams for the associate data engineer in SQL. Okay, so the question is, from the time when I registered for the certification exam, it's reading 30 days, while on the assignment you gave us, we have up till 30th to complete the certification. Is the disparity in the timeline? I don't understand. Are we supposed to stick with the timeline from the day we registered for the certification, or for with the timeline that you gave us, which is expiring on the 30th?
Okay, so now the one I gave is actually according to our own schedule. Now, by our own schedule, everyone was expected to register on the 1st of September, and the whole of September was just to would have been to was dedicated to getting the certification. So from our own schedule and timeline here, everyone is expected to register on the 1st of September, and 1st of September to end of September is 30 days. So that's why you have that on your own board. However, follow the one you have. Since you have already registered, at least you've registered before the deadline, it counts for something. So since you've registered, I'm very sure that you would want to complete it before the 30 days elapses. So since you've registered, just ensure you complete it before the 30 days on data camp elapses.
Okay, thank you, ma'am.
All right, you're welcome. So since no hand is raised, I want to believe that we do not have any other question or any concern again for today. So I want to say thank you for joining in, and hopefully we'll run live classes next week. I'm still trying to figure something out here, because anyway, we'll see how it goes next week. Let's see how it goes next week, Sha. So thanks for joining today, and please enjoy your Saturday. I've sent the attendance link. I have sent the attendance link. Let me
Thank you.
resend it. All right, you're welcome. I have resent it. Please make sure you write your attendance before you leave the call. And thank you all for joining in today.
Thank you very much.
You're welcome.
Hello, I can't hear anything. Or is the call still on?
No, the call has ended. We must stay here. That
Sorry,
has ended.
sorry.
The call has ended. Just sign attendance. And then the call has ended. The meeting has ended.
Please, I didn't have the link. Can I get the link?